Hey, so this is just a quick video to go over one particular problem or type of problem that gives people a lot of grief on the homework. Normally I do this as like a warm-up at the beginning of class, but doesn't really make sense now. So I just thought I would do this as a separate video. All right, so let's see. Here is the problem. And you will see something very similar to this on your homework. Pretty much everyone will have something similar, maybe different numbers in different spots. But this is just an expected value problem. The only difference from this and what we were doing in the last video is that it is just written maybe a little more mathematically than you like to see, but we know how to do all the steps to solve this problem. And so here we have the probability of, well, let's back up. These are the, let's see, 6 numbers that we have in our sample space. So it's like saying, if I roll a die, there's 6 numbers on it. 1, 2, 3, 4, 5, 6. Only in this example, it's 1, 4, 8, 16, 32, 64. That's all. And so the probability of rolling a 1 is given as 1 over 32. So we're going to need that for our problem. So we'll have the probability of a 1. But then the probability of all the other numbers is given by a formula. And so the formula kind of looks scary, but it's not terrible. It's saying 2, if you write your number as 2 to some power, so everything in S, everything in our sample space is a power of 2. If we can write it as 2 to some power, then our probability is going to be 2 to the 1 minus that power. So first, let's just write everything as a power of 2. So we don't need to worry about 1 because 1's taken care of. So 4 is 2 squared. 8 is 2 to the 3rd. 16 is 2 to the 4th. 32 is 2 to the 5th. And 64 is 2 to the 6th. The first couple were easy. We all know 2 squared and probably 2 to the 3rd. And then as you continue, hopefully you notice the pattern is the number just doubled from 8 to 16. We just had another 2 times 2. 16 to 32, we doubled again, so we had another 2, and then 32 to 64, we doubled again. So that's how I was able to get those last few fairly easily. Okay, so for this problem, we want 1, which we already have. And then we want to use 8, so we're going to use this for the formula, 32, and 64. Those are the numbers that we're finding the expected value of. So in order to find our expected value, we are going to take our number. So let me do the numbers, and I'll do them in green. We have a 1, an 8, a 32, and a 64. And then I'll scroll back up when I need that. But then we're going to multiply by the probability. We write it. We're going to multiply, there we go, times the probability of 1. Multiply the 8 times the probability of 8. Multiply the 32 times the probability of 32. And finally, multiply the 64 times the probability of 64. So we're taking all of those 4 items listed in E, 1, 8, 32, 64, taking all those 4 items, and we are going to multiply those numbers times the probability of those numbers. All right, so the first one is easy because it was already given to us. So this becomes 1 times 1 over 32, because right here, probability of 1 is 1 over 32. I don't really need to do anything for that. What I'm going to need to work on is the probability of 8, the probability of 32, and the probability of 64. And that is where I'm going to use this second formula here. So let's just erase extra stuff. And for the probability of 8, we said that 8 was 2 to the 3rd power. So I'm going to say the probability of 8, or the probability of 2 to the 3rd power, equals 2 times 1 minus 3. Because you have this k right here, and then that's the same as the k right there. So for this example, since 8 was 2 to the 3rd, our probability is going to be 2 to the 1 minus 3. So we have 8 times 2 to the 1 minus 3. For 32, I don't know why I didn't keep my color scheme going. 2 to the 1 minus 3. 32 is going to be 2 to the 1 minus, well, what's 32? I'm going to go up here. 32, I know I'm marking all over this, but at least it's a different color. 32 is 2 to the 5th, so our probability is going to be 2 to the 1 minus 5th. Because now, going back to our formula, I'm trying to find the probability of 2 to the 5th, so that's going to equal 2 to the 1 minus 5th. And then finally, I have 64 times the probability of 64. Well, what's the exponent on 64? So I go back up here, I see a 6. So 2 to the, how gracefully can I do this? Oh, that's not terrible. 2 to the 6, yes, that is terrible. 2 to the 6 is the same as, or the probability of 2 to the 6 is going to be the probability of 2 to the 1 minus 6. All right, so the first guy, our 1, that's already taken care of. Next up, we have 8 times, and then 2 to the 1 minus 3 is 2 to the negative 2. 2 to the negative 2 means to put that number in the denominator, so that would become 1 over 4. Notice I kept the 8. All I was changing was that fraction. All right, 32, and now we're going to do this one again. So 2 to the 1 minus 5, well, 1 minus 5 is negative 4. So this becomes, let's just work it out one more time. 1 minus 5 is negative 4. So that is 1 over 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. So that goes over 16. And then finally, 64 times 2 to the negative 5th power. So what is, that means it's on the denominator, and the 5th power is 32. We just did the 4th power right here with 16. So I needed to double it and get to 32. All right, so all that's left is reducing and adding. So this becomes a 2, and this becomes a 2. This becomes a 2. So we end up, without even a calculator, just adding that off the top of my head, I get 2, oops, I'm trying to move my face out of my pen. 2 plus 2 plus 2 is 6, and 1/32. It says to give your answer as a fraction in simplest form. So usually that means an improper fraction. I don't know if it would take 6 and 1/32, so I just like to use improper fractions. I don't know 6 times 32 off the top of my head, so I'm going to use my calculator. I got 192, so this becomes 193 because of that extra 1 on top over 32 as an improper fraction. All right, so just like always, I kind of went through that, not just like always, but I feel like I kind of went through that a little fast in some spots. So now, just like always, you can always pause or rewind any parts that you want to see again. All right, short and sweet. I will see you in the next video. Bye.